Good morning, children. Welcome to your chemistry online class. We have successfully completed our all topics. Today onwards, we are starting new revision. So, for the revision, we are starting with the chapter Classification of Elements and Periodicity in Properties. This chapter is very important because you can expect a lot of questions from this chapter. And you can score well in this chapter. So, the maximum questions will be from this chapter. So we'll see what are the major points we have studied there. Let's recollect. So this first part of this chapter, the history of periodic table, that is deleted. So you no need to study all those things. So we have to study from the modern periodic table. What is modern periodic law? The modern periodic law, we know the physical and chemical properties of the elements, which is the periodic function of its atomic numbers. This is the modern periodic law. He is the founder of modern periodic table. Modern periodic table, which consists of the horizontal rows, which called periods, the vertical columns are known as groups. How many groups and periods are there in the periodic table? Yes, there are 18 groups and 7 periods in the periodic table. And we know the periodic table is divided into 4 blocks. What is the basis of this division? Yes, the division of this periodic table is based on its electronic configuration. That is, the outermost shell. In the outermost shell, if the last electron enters to the S shell, then we can say the element will be in the S subshell. If the last electron enters to the P, then we can call it as it's a P block elements, similar to D and F. And we know in S block there are two groups, group 1 and group 2, alkyl metals and alkaline metals. And I hope you remember what are the properties of these elements. They are very reactive, low ionization enthalpies, metals, and all those things we have already discussed. So these are very important points. First you have to remember what are the properties of the periodic table and what are the properties of each block and what is the basis of the classification in each block and what all the groups are belongs to each block. So we know in the S block, first group and second group. What about the P block? Yeah, in the P block, group 13 to 18 are there in the P block. And they are known as representative elements or main group elements. We know in P block, it consists metals, non-metals, metalloids, everything. I hope you remember what are the groups, the families, carbon family, nitrogen family, oxygen family, and all those things we have discussed very clearly, and you can expect questions from this portion also. Next one is D block. Its general electronic configuration is N-1, D 1 to 10, N is 1 to 2. So they are very special because they shows catalytic properties, forms colored ions, show paramagnetic properties, form complexes, etc. So you can expect questions from here. What are the speciality of D block elements or what is the general electronic configuration of D block elements? Such questions you can expect. F block, that is in the down part of the periodic table, we know, and the general outer electronic configuration there. So children, you have to study all the general outer electronic configuration for both all the four blocks for F, S, P, D and F. You must study this. It's very important. So in the one word part or 1 mark question part and all, you can expect such questions. And that will reach the core of this chapter. Very important. You can expect maximum questions from this part. Trends in physical properties. So you have to be thorough with all these properties: atomic radius, ionic radius, electron gain enthalpy, electronegativity, oxidation states and chemical reactivity. It's very important, children. You can expect many questions from here, and all application level questions you can expect from this part. For that purpose, first we should know what is atomic radius, or what are this atomic radius, ionic radius, and all these things. We'll see how will be the trends in the physical properties. These are the physical properties of an element. So in the periodic table, each group or each period will show some trends. We'll see one by one. First one is atomic radius. First we should know what is atomic radius. Children, what is atomic radius? Yes, atomic radius is the distance from the center of the atom. What is the center of the atom? Nucleus. So it is a distance from the nucleus to the last shell, outermost shell. So as we check in the periodic table, general trend, atomic size generally decrease across a period. Why? Because within the period, the outer electrons are in the same valence shell. So the effective nuclear charge increases, the atomic number increases. So there will be increased attraction between nucleus and electron. That's why size will be decreased. But if you take in a group, in the case of a group, we know as moving down, atomic number increases, as number of shells increases, so size of the atom will be increase. Here you can see size of atom. This will be the general trend in the group. This is the first group, this is 17th group. Next one is ionic radius. What are ions? We know cations, anions and all. The removal of an electron from an atom results the formation of cation. That is either removal or addition. If an electron is removed from an atom, we'll get a cation, a positively charged ion. When atom gain an electron, we know it leads to an anion. Cation is always smaller than its parent atom, while an anion is always greater to its parent atom. So, such question also you can expect. For example, they will give some of the examples. For example, last exam also we have seen a question like this. They will give some type of ions. They may ask from that to identify the electrons or arrange these substances based on their size. Such questions you can expect. And other important thing in this there is isoelectronic species. What is isoelectronic species? That is two or more species with the same number of atoms, same number of valence electron and same structure. This is known as isoelectronic species. If two atoms having or atom or ion or substance having same number of electrons, valence electron, then we can call it as isoelectronic species. And this is also important, and you can expect question like this also. They will provide so many elements, ions, atoms, etc. From that they may ask to arrange or classify them as isoelectronic species or identify isoelectronic species of any atom. Such questions also you can expect. Next one is very important, ionization enthalpy. So you should know the definition of ionization enthalpy. It's a quantitative measure. It is a tendency of an element to lose electron given by its ionization enthalpy. It is the amount of energy required to remove the most loosely bound valence electron from an atom. So its unit is kilojoule mole inverse. So there is first ionization enthalpy, second ionization enthalpy, third ionization enthalpy, etc. And ionization enthalpy is always positive because we need to provide energy to an atom. So this always will be positive. The second ionization enthalpy will be higher compared to the first ionization enthalpy because it's more difficult to remove an electron from a positive charged ion. If we first remove an electron from an atom, then it became cation. If we should provide a lot of energy to remove the electron from the cation. So the second ionization energy will be always greater than the first ionization energy. Similarly, the third ionization energy is also greater than the second. Here you can see the trend in the ionization energy in the first group elements. So in a group, the ionization energy will decreases, but across a period, the ionization energy will increase. One of the anomalies is lithium. That is because of we know some cases. Express such question: why are lanthanides and actinides placed separately at the bottom of the periodic table? And elements like zinc, palladium, cadmium are not considered transition elements. Why? Because they have completely filled the orbitals. So such application level questions or reasoning type questions also you can expect. Next one is electron gain enthalpy. It is the amount of energy required to add an electron to the valence shell of an atom. So it will become anion. So we are supplying energy. So electron gain enthalpy. So it will be negative. Sometimes it will be negative, sometimes it will be positive. Depending upon the element, it will be positive or negative. As a general rule, we can say that electron gain enthalpy becomes more negative with increase in the atomic number across a period. Next one is electronegativity. It is the ability of an atom to attract the shared pair electron. Fluorine has the highest electronegativity value of 4. So as the O hole, we can see other general trend. How the atomic radius vary in group. We know in the group atomic radius increases. In a period atomic radius decreases. Electronegativity in a group it's increasing. It's decreasing down. In a period it is increasing. All trends generally we can see here. This one is oxidation state. Chemical reactivity. That there we have to study very important thing, diagonal relationship. That is certain pairs of diagonally adjacent elements in the second and third period show similar property. For example, lithium show the properties of magnesium. Beryllium shows the properties of aluminium. Boron to silicon. This is known as diagonal relationship. Why they are showing diagonal relationship is the first reason is they are very small compared to all other elements, and there is lack of d orbitals, and this charge by radius ratio is very low. These are the reasons. You have to know why they are showing these properties, and such application level questions also you can expect. And some general terms. Italic character decreases from right to left. We know